1, 2, 3, 4. One, two, three, four. 1, 2, 3, 4. 4. 4. Hello test, hello test, hello test, hello test. Hello test, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 4. What time is it? 1, 2, 3, 4. Hello test, 1, 2. One, two, three, four. Hello, test, hello, 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 hello. Hello, hello, hello. 1, 2, 1, 2, 1, 2. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. VK 3 CSJ testing. Hello, test, hello, test. Hello, test, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 4, 4. 4, 4. I'll leave that there. 1, 2, 3, 4. Hello, 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 hello. 1, 2, 1, 2. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. VK 3 CSJ testing. Hello test, hello test, hello test, hello test. Hello test, hello test, hello test. 1, 2, 1, 2, 1, 2. 1, 2. Where's the 1, 2, 1, 2. VK3 CSJ. Stand by for the ASV broadcast at 10 o'clock on 3541. 1, 1, 1, 1, 1. It'll have to do. VK3 CSJ. Good evening. This is VK3 EKH, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria with the regular Friday night broadcast, coming to you from the studios of VK3 CSJ in Narre South. We're broadcasting on the prime frequency of 3541 kilohertz in the 80 metre amateur radio band, and also via the Melbourne television repeater VK3 RTV digital channel 1 in full living colour and HD at the same time. Also broadcasting on my Discord channel, and that's it, Discord stream. So if you are registered on Discord and go to my qrz.com page, I provide a universal link of sorts that allow you to go to the astronomy chat room, and associated with the astronomy chat room is the HD stream, which is far better to watch because it's less than a second delay to what you're hearing on 80 meters to what the vision is, unlike YouTube, which gives you anything up to 20 seconds delay. So Discord is far better. If you haven't registered with Discord, it's a fairly simple process, although maybe a little bit involved. But once you a simple process, but it's involved. Yes, you can use those two terms in the same sentence, I guess. But nevertheless, once you've registered on Discord and everything goes through okay, don't forget your password is all I can say, because if you do forget the password to access your Discord or whatever, it will be a tricky one to get that one sorted out. But there is YouTube, and that's the next best thing. But of course, like I say, the Melbourne television repeater is ultimately the best for visions. You just got to be able to receive the repeater. So just trying to keep an eye on my audio levels. I'm hoping that everything is okay. I'm just peeking into the red on the vMix, which means that YouTube level should be okay. And Discord is also working. I can see that changing colour as I modulate. So g'day to Steve, VK3SPX, and g'day Stuart, VK3UAO, and VK3FST Sam. G'day Sam, welcome to the mix. And g'day Mike, VK3XL, the local ham up the road. They're all watching me on Discord, so join Discord. And the chat room, let's have a quick look at the chat room. Kim. Okay, no one's there at the moment, but that's all right. All right, let's just go back to visions. Right. Now, we've got a few things tonight. We've got a space weather report from Tamitha. She released a video about 11-minute video about, it's 11 minutes, 11 hours ago, I think it was. So it's fairly current up until Monday at least. And so we'll be running that in a short while. Okay, so let me just give the usual spiel for the ASV. Where do we first go to for that information? That'll do. Just there's the other alternative thing that I read out. The ASV is a non-for-profit society, or as it's worded here, non-profit society for people interested in astronomy, attracting and catering for people from a wide range of ages and backgrounds, abilities and interests. First formed in 1922, the society has grown to over 1,000 members, and its activities are coordinated by a council of elected office bearers, section directors and ordinary councillors. Where was I? The ASV has weekly activities at our two metropolitan locations. One's the Morley Community Village and the other is the Melbourne Observatory itself. And we host monthly Astro Talks at the Herbarium near the Melbourne Observatory. Yes, it should be coming up to an Astro Talk actually. The Society's library is also located at Melbourne Observatory and is open during our Astro Talks. For over 50 years, the ASV has played a major role in the care of the buildings and facilities at the Melbourne Observatory. Our members conduct astronomy for the people gatherings throughout the year, bringing telescopes and astronomy to Melbourne's parks and schools. Please check the calendar on the ASV website for details if you are interested in attending one of these public events. ASV is currently involved in a number of major projects. We are involved in the restoration of the Great Melbourne Telescope and are also currently working on the installation of a series of remote telescopes at our dark sky site, which once completed will be accessible to our members for use. In fact, most of that particular project is now complete, as far as I know. Thanks to a generous donation from one of our long-standing members, respected members, the Leon Mao Dark Sky Site located north of Melbourne has a pristine night sky for deep sky observing. The ASV has a 25-inch telescope and a 40-inch telescope and a wheelchair accessible 16-inch telescope at the LMDSS, and makes use of the existing telescopes at the Melbourne Observatory during some section meetings and our members' nights held once a month at the observatory. There's also a fully steerable 8.5 metre radio telescope, very similar to the one that the former Doug MacArthur, VK3UM, has at his property up there at Redburn. I think it's Redburn. And anyway, remember, getting involved with the radio astronomy section of the ASV will allow you to be involved with the experiments being conducted on that dish. There's also an annual yearbook supplied to members, which is something like this. I usually hold this up so you can see what this yearbook looks like. That is a yearbook, and it is kind of like an almanac of sorts, but full of all sorts of interesting information for the optical astronomer. And there's also a bi-monthly newsletter which is called Crux, and that is this one way over here. If I can just pick it up without dropping my light. My side lamp here has just gone to a 45-degree angle, but it's been saved going to the floor from a curly cord on a microphone. Anyway, that's the Crux newsletter, or magazine they refer to it now. Nice and glossy and beautiful publication, and smells good when you open it up. It's important. Yeah, right. Oh, this damn chair. The ASV logo, which is this chap on the front of the magazine, the ASV logo, that one there, sports the crux and the pointers, 2 pointers. And there's although it's not, is it written there? No, it's not, but there is a Latin motto associated with that symbol. And it is, the Latin word stands for this way to the stars. The ASV is governed by a set of rules which should be read before applying for membership. And there is a link to that there on that page. Any person or organisation with an interest in astronomy may apply for membership of the society. And all that information that I just read is under the About Us tab, and you can see all that for yourself. And of course the link to the ASV rules is there. The Join It Now tab is there, and there's a whole list of past presidents from 1922 to current, and a list of honorary life members. Okay, there are Yes, I didn't need to do that. Anyway, there, I just to quickly go through the sections. There are about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Used to be about 20 sections that made up the ASV, but some of those sections have temporarily closed down because of no section director to run it. But anyway, the sections are astrophotography, club section, comet and meteor section, computing section, cosmology and astrophysics, deep sky, historical section, instrument making, juniors, lunar and planetary, new astronomers group, radio astronomy, solar astronomy, and space exploration. If any of those sections sound of interest to you, get in contact with the various section directors for those sections and see if you can be invited along to one of the meetings, either a personal meeting, like a group meeting, or via Zoom. It all depends on how they do it. What else? I think that's about it, really. So any information about the ASV, go exploring the website at www.asv.org.au. That's www.asv.org.au, which is that on the screen, as you can see, that one there. So there it is. I think we'll finish up there and see you all next week. Sky notes. Just a quick rundown of Tanya Hill's Sky notes for the month. Mercury, if you're interested in looking at Mercury, actually before I read that out, when observing planets over a period of time, we notice they're changing positions against the fixed background of distant stars. It is easily to notice for the inner planets, Mercury, Venus, Mars, as they orbit faster compared to the slower outer planets like Jupiter and Saturn, Uranus and Neptune, which have a more subtle change in position. Learn about growth of understanding the planets in the solar system, including a video presentation by astronomer Dr. Tanya Hill at the Museums Victoria Picturing the Solar System. As I said last week, that's a link on the Sky Notes page. That Museums Victoria Picturing the Solar System is a URL link. In fact, I'm not sure why I haven't downloaded that. I might have been able to, it depends on how long it goes. I'd have to check that, but I might be able to actually show that here. Dr. Tanya Hill, I've met her. Nice lady. Now, Mercury is drawing near to the Sun, yet remains visible in the early part of the month from 5 a.m. in the east before it fades by 6:30 a.m. at the dawn. By late May, it will be lost completely in the morning's early light. Venus, however, as the morning star, can be seen from 3:30 a.m. to in the east, reaching its highest elongation this month before fading in the dawn light. Mars remains visible in the evening from 6 p.m. in our northern skies before setting at 11 p.m. The red planet will appear as a set of. The red planet will appear and set a little earlier each evening during the month, so that by late May it will be set by 10:30 p.m. Jupiter is about to move behind the Sun for its solar conjunction, but this month it is still visible in the northwest from 5:40 p.m. before setting at 7:30 p.m. Each evening it will appear earlier, and by the end of the month it will set by 6:30 p.m. Saturn has merged from its solar conjunction to be visible in the east in the early morning, 3 a.m, before fading in the dawn light. It too will rise progressively earlier, so that by month's end it will appear from around 2 a.m. Meteors. Now, hasn't there been a lot of stuff in the media about meteors this last few weeks? The Eta Aquarids meteor shower, which began on the 3rd, peaking on the 6th, and the media's been hyping over it. The shower is linked to the comet Halley, and rates can be reaching anything up to 55 meteors per hour. But in most cases, you'd have to be able to see something like that. It would have to be during the peak period and at a dark sky site where the light from the city is less. The meteors are generally the size of a rice grain, sand. They're very fast at 64 kilometres a second, usually yellow, with persistent trains, and enter the atmosphere 100 kilometres above the surface. They appear in the constellation of Aquarius, hence the term Eta Aquarids, and the radiant, or the point from which they appear to originate, rises at 2:30 a.m., around 2:30 a.m., moving higher to the northeast by dawn. All right, so the Eta Aquarids is still potential, but at this time you'd be probably lucky to see much that you can say, wow, look at that. I think long gone are the days where meteor showers were quite significant. I mean, I've heard stories, and I think we've all heard stories of meteor showers that have been really outstanding. Hundreds an hour and more. So I think it's a bit fading away. So I'm going to go straight to on this day, because I didn't finish off all the on this day last week. I think the last thing I said was, I don't know what it was. Space shuttle. No. I'll start off. What's today's date? It's 9th. No, I think I already said that out. Yeah. I think we'll start off with the 19th. 19th of February, 1961, Verona 1 USSR makes the first pass of the planet Venus, in this case Venus, although contact with Earth by then had been lost. 1961. On the 20th, 1990, Hubble Space Telescope sent its first photograph from space and an image of a double star 1,260 light years away. On the 21st of May 2010, the launch of Icaros spacecraft made by Japan, the first successful solar sail technique used for planetary travel. On May 25, 1961, President John F. Kennedy launches the USA's race to the moon. Also on the 25th of May in the year 240 BCE, first recorded close pass by of sun of comet Halley. Okay, geez. So 25th of May in the year 240 BCE, that was the first recorded close pass of the sun, or by the sun, of the comet Halley. On the 28th of May 1959, monkeys Abel and Baker are sent on a suborbital flight of 580 kilometres into space in the nose cone of a Jupiter rocket. Also on the 28th of May in the year 585 BCE was a solar eclipse. Occurs during a battle between the Medes and the Lydians. knowledge of past eclipses has enabled dating of other historical events. Okay. Also on the 28th of May 2002, water ice on the red planet is discovered by Mars Odyssey. On the 29th of May 1919, Einstein's general theory of relativity is confirmed by Arthur Eddington's study of distant starlight bending during a total solar eclipse. On the 29th of May 1794 was the birth of the first astronomer to map the Moon and Mars, Johann von Madler. I think that's how you pronounce that. And finally, no, there's two more dates. On the 30th of May 1975, European Space Agency is created, ESA, by merging launch development and space research organisations. So the ESA, European Space Agency, is a merge of two space firms, I guess, launch development and space research organisations. Launch development, never heard of it. And finally, also on the 30th of May 1966, launch of Surveyor 1, which will make the first landing on another body, in this case, the Moon. Thanks, Tanya, for the Sky Notes and on this day. Always interesting to read the historical aspects to what goes on and what has gone on. You're tuned to VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with a regular Friday night cast. Okay, 10:22. Oh, now before I continue on with this little story, courtesy of astronomy.com, but we'll get there in a second, I just thought I'd wait 22 minutes into the broadcast for other latecomers to tune in. This is an interesting little camera. Just pulling it out of its little satchel here. Satchel carrying case. There we are. For those watching video, isn't that an interesting look? Well, that is an interesting camera. Have a look at that. It's if that will just focus on it, it would be really nice. It's just going to look. Everything's going to be out of focus. Sorry about that. Anyway, the idea of this camera is that it slides into the eyepiece of a telescope, and I can't focus on that. There you can just see the CCD in there, and it's connected via a little Wi-Fi link. There's the antenna on the back there, little Wi-Fi link, and that goes straight to your mobile phone. So put that into the eyepiece of the camera, get your mobile phone, and the mobile phone sees what this sees, or what the telescope is seeing. Now, I haven't tried it on a telescope yet because I haven't quite got that far yet, but all the advertising for it shows that's what you use it for. And anyway, this is the box that it comes in for those that are watching TV. It's an LST22, and just making sure that there we go. There's a bit of, it's now focused, or it was in focus. Bring it across a bit. There we go. Now it's in focus. So yeah, I thought that was interesting. I think that company's in Tasmania. I think the camera came from Tassie, believe it or not, although it probably originally came from China. But anyway, once I get a telescope set up down the back, made in China, yeah. But everything's made in China these days. Yeah, there's the barcode if you want to scan it quickly while I've got it in camera there. There you go. Quick, scan it. Anyway, so there it is. But it works. and but I don't know how well it works yet. It's got a USB-C for charging. It's got an SD card for putting in an SD card, and a reset, and that's about all there is on the back end of that. I'm not sure if I can get a quick focus on that. No, it's not going to do it. Anyway, just thought I'd show that, and I'll let you know how well, in fact, it does work, because that was only over $100. Not very expensive. That's the little booklet that you get with it. Virtually useless booklet, but you have to download the ones on downloadable is far more substantial, as you can imagine. And whilst I'm on that note, as you will know, but I have been for the last 2.5-3 years organising a scope dome in the back paddock, and these last 2 days, Thursday and today, I've had the team from Sidereal Trading out, and they've assembled the dome finally. I now have a fully operational scope, 3-metre scope dome. So I do have several pictures, but I just haven't got anything across to this computer. So I shall try and show you that next week with perhaps a little bit of video as well. But all I can say is the pain of waiting for this particular project to come to fruition has finally happened. So my heartfelt thanks goes to Diego and Mark Oscario, the president of ASV, who both came out yesterday and today to assemble this dome. It's been sitting on a pallet since October 2023. The rats got into it, so I'm trying to get the smell of rat poo out of it. But basically it's now functional, so all I need to do now is get a telescope in there, so that'll happen over the next period of time, hopefully not another 2 years. But I want to try this thing out. I want to see how well this little camera works, if it does in fact do anything good at all. Because what I'm trying to say is, even though this camera is designed to slide into an eyepiece on a telescope, yet to be convinced about that. Normally cameras for doing planetary photography or deep sky photography are a lot more expensive because they are specialized. They are deliberately designed cameras which are incredibly sensitive and very low noise, thermal noise. Some of the cameras are actually cooled to minimize the thermal noise on images, and they're the cameras that I'm after in actual fact, in due course. So but you know, even your mobile phone up near an eyepiece of a telescope works amazingly well. It's been proven, so all good stuff. All right, you're tuned to ASV Radio, VK3EKH. Now we're going on to an article from astronomy.com. It's called "Do Black Holes Exist Forever?" And there is a graphic with this. So I shall just bring up the Z graphic. I can't find it because I didn't bring it across. Just bear with me. I just have to go hunting for this image that I do have. There it is. Why didn't I bring it across? I don't know. All right, this is the graphic that we're about to talk about. Okay, do black holes exist forever? In 1974, Stephen Hawking proposed that black holes can evaporate. And in this particular picture you're seeing on the screen here, Hawking radiation, proposed by Stephen Hawking, could cause black holes to slowly evaporate over time. Quantum fluctuations in space-time can cause pairs of virtual particles to pop into existence and then immediately annihilate each other and disappear again throughout the universe. But if such a pair appears right at the event horizon of a black hole, one particle could fall in while the other escapes, carrying away a minuscule amount of energy and therefore mass from the black hole. That's what they're saying, and that's what that drawing is meant to illustrate. So, do black holes exist forever? If not, how do they die? If yes, is the number of black holes in the universe always increasing? Is the question being asked by someone in Florida. The answer to that is black holes are known for their voracious appetites, consuming everything in light that falls inside them with no hope of escape. But in 1974, Stephen Hawking proposed that in fact black holes do evaporate. Everywhere, all the time, infinitesimal particles are popping into and out of existence. They appear in pairs that instantly annihilate each other. Thanks to quantum mechanics for this weirdness, in brackets, close brackets. But right at the event horizon, the black hole's point of no return, sometimes one particle in a pair will fall into a black hole and disappear. Its partner then would zoom away, meaning the black hole has emitted energy and grown a little smaller. Hawking reassures readers that it would take far longer than the age of the universe for this completely evaporate even a solar mass black hole. But what about a tiny primordial black hole? Well, this could indeed evaporate entirely, it is thought, and the process is one that speeds up as it progresses, leading to a large burp of energy in the black hole's final moment. In Hawking's own words, he says, this is a fairly small explosion by astronomical standards, but it is equivalent to about 1 million 1 megaton hydrogen bombs. Yes. It's one of those questions that somebody likes to ask. You're tuned to ASV Radio, VK3EKH, where the time is 22 minutes to 11. And our next article, which is a leftover from last week. Astronomers find a strange pulsar blinking in slow motion. And we have a graphic of a pulsar, which is this guy here. And PSR J0311 plus 1402 flashes every 41 seconds. Quite slow for a pulsar. It could help bridge the gap between fast and slow spinning radio sources. So anything to do with radio I'm always interested in. About 2,600 light years away, a dead star is sending signals from beyond the grave. Astronomers recently found the strange beacon, which appears to be a pulsar blinking in slow motion, something that shouldn't be possible, it seems. It's incredibly exciting to discover such a long-period pulsar, says Youngming Wang, a postdoctoral researcher at the Swinburne University in Australia and the lead author of a paper about the discovery published March 28 in the Astrophysical Journal Letters. But what's even more exciting is that the new technique we used is opening the door to finding more hidden objects in the cosmos, he says. Scientists now plan to look for more of these oddball objects, which could help to bridge the gap between traditional, well-understood, fast-rotating pulsars and those few that rotate seemingly impossibly more sluggishly is the words that they're using here. Slow and steady. Pulsars are like high-speed cosmic lighthouses. They are made of the dense cores left over from massive stars that ran out of nuclear fuel and went supernova. Following the explosion, what remains of the stars collapse into a 6-mile wide or 10-kilometre wide neutron star. Because the star's original angular momentum or spin is conserved, being squished down into a small object means its spin actually speeds up. The same way a figure skater whirls faster when they pull their arms in. Pulsars emit beams of radiation from their poles. These beams then sweep across the universe as they spin. If those beams happen to point toward Earth, we receive a flash of light with each rotation, typically at radio wavelengths. Pulsars throb with clockwork precision, literally, with the fastest flutterers blinking tens of thousands of times per minute. Even the slowest ones tend to flash at least every 10 seconds. But in 2022, astronomers found an object emitting radio pulsars like a pulsar, but far more slowly, only about every 18 minutes. Since then, scientists have discovered a handful more of these objects, known as long-period transients, with periods that range from minutes to hours. You'd think these could just be very slow spinning pulsars, but there's a problem with that explanation. A pulsar's energy comes from its spinning motion. Despite their regularity, pulses are in fact gradually slowing down, and the energy lost in that deceleration is converted into radio beams they emit. Long-period transients can be sluggish pulsars because they are already spinning so slowly that the further loss in rotational energy is no longer enough to power the beams as strong as the ones we see from them. The point at which a pulsar rotates too slowly to produce radio beams is called the pulsar death line. Pulsar death line. Oh dear, it's the first time I've heard of that. Is called the pulsar death line. Pulsars that fall below this line stop emitting radio beams, so we stop seeing them as pulsars, of course. I'm thinking of the Green Mile. Is it the Green Mile? That film with Tom Hanks in it? The Green Mile. Dead Man Walking. Yeah. It's a good film, though. Horrible, but good. Anyway, so long period transients can be slow and so bright that they are caused by the same mechanisms as rotationally powered pulsars. Some might still be neutron stars behaving in unexpected ways. Others could be different objects altogether, such as white dwarfs or binary systems. Finally, a missing link. The recently discovered pulsar called PSR J0311 plus 1402 may offer new clues. With a 41-second period, it spins much more slowly than typical pulsars, but much faster than long-period transients. And astronomers think that this middle-of-the-road object could be a missing link between the two populations. Scientists spotted the stellar strobe with the Australian Square Kilometre Array Pathfinder ASCAP and followed up with the other radio observatories to measure its luminosity, period and polarization, all of which strongly indicate that it is a pulsar. But it is still spinning too slowly to be powered solely by rotation. It doesn't fit neatly into the leading theory of how pulsars emit radio waves, Wang says. If a pulsar spins too slowly, we wouldn't or shouldn't see any radio emission at all. Yet this object is very slow, leaving astronomers wondering where the energy powering its beams is actually coming from. Studying the strange beacon and finding more like it could help astronomers learn more about how long-period transients generate their beams. He says, I think there should be more objects like this waiting to be discovered. Right now, we see a gap in rotation periods between known pulsars and long-period transients. Traditional pulsar search methods haven't typically looked for objects spinning slower than 10 seconds, which means we could have been missing them simply because we weren't searching for them at all. Astronomers typically find pulsars using a single large radio telescope, which can't easily detect flashes less than about 1 every 10 seconds because slow signals are fainter and more easily lost in the background noise. Long-period transients are usually found using arrays of multiple radio antennas working together, a method called interferometry. This method is less sensitive to fast blinkers because combining the signals from multiple telescopes takes long enough that it can blur or even erase rapid changes from data. That leaves pulsars with medium periods like PSR JO311 plus 1402 in a blind spot for other methods. But that's changing. As this discovery shows now, we're using a new system with ASCAP called it's an acronym. It's called CRACO. That's not really a word, but it's anyway. That's the words for it. CRACO. I don't know whether they tell you what that stands for. Can't see it straight away. So we're using a new system with ASCAP called CRACO, which is perfect for catching objects in this missing range, Wang says. It's the system that found PSR JO311 plus 1402 and could help astronomers figure out where pulsars stop and long-period transients begin, or whether they are more similar than we believe. Answering these questions will help us understand the entire neutron star population and what powers their emissions. The discovery and the mystery shows how much we have left to learn about the cosmos. With the new radio facilities coming online, we might find loads of weird stuff in the sky, says Michelle Collins, an astronomer an astronomy lecturer at the University of Surrey in England, who was not involved with the study in a podcast. We may find that this is the tip of the iceberg, which with many more long-period neutron stars waiting to be discovered, Collins said to Astronomy. Wow, we finally got through that. So that article is courtesy of astronomy.com, and look under, back to list, look under the current news tab. Astronomers find a strange pulsar blinking in slow motion. Okay, you're tuned to ASV Radio, VK3 Echo Kilo Hotel. All right, I think we've got time for this. Maybe not, I don't know. Let me think. Let me see, what else have I got here? Oh yeah, is that a small article? Yes, that's a small article. I'll do that before going to Tematha. All right, changing the picture on the screen. We have this amazing image. All right. And just note that the amazing image was not me. Courtesy of Science Alert on the 5th of May, this image on the screen that you are seeing right now, almost every speck of light in this incredible image is a galaxy. All these galaxies appear in a tiny patch of sky. If you ever wanted to get a bit of perspective, there's very little that's more humbling than a good deep sky field or deep field image from the JWST has dropped a real showstopper. In the latest image release, the powerful space telescope grazed back nearly 12 billion light years into a tiny patch of sky, less than a fifth of the width of a full moon. That little patch of sky is teeming with glittering lights. It looks a lot like any patch of the sky seen when you look up from the ground on a cloudless night, with one major jaw-dropping difference. Most of the lights in the new James Webb Space Telescope Hubble composite image are not bright stars, but galaxies stretching back almost as far across space-time as the beginning of the universe. You can tell the difference because only the stars have the pointy diffraction spikes that are characteristic of the James Webb Space Telescope image. This pattern is generated when light from a concentrated point source bends around the edges of the telescope. The light in galaxies is much less concentrated, so it doesn't produce the same effect. This makes it easy to identify foreground stars in the James Webb Space Telescope images and tell them apart from background objects. The focus of this particular image is a group of galaxies concentrated just below the centre, glowing with a kind of golden light. The light from the group of galaxies has travelled for around 6.5 billion years to reach us, nearly half the 13.8 billion year age of the universe. The observations were taken as part of the Cosmos Web Survey, a project aimed at cataloguing groups of galaxies to better understand the evolution of the universe, which includes the cosmic web. The distribution of galaxies throughout the universe isn't random or higgledy-piggledy. They organise themselves into clusters connected by an invisible cosmic web of dark matter and hydrogen. Combining the JWST data with X-ray data from the Chandra X-ray Observatory reveals just how large this group is. The most massive identified in the view field. The hot gas that suffuses the cluster glows in X radiation powerfully enough for Chandra to detect. There is, however, a lot more to be seen in the image if you know how to look. In a catalogue compiled from this data, an international team of astronomers led by astrophysicist Greta Toni of the University of Bologna has identified 1,678 groups of galaxies, not 1,678 galaxies, but 1,678 groups. This is also nothing special about this little patch of sky, measuring only 6.44 by 6.44 arc minutes. The full moon, for context, is about 30 arc minutes across. Every other tiny patch of the sky should be just as teeming with galaxies, thousands upon thousands that can be imaged in an area smaller than your pinky nail. If that's not awe-inspiring, we don't know what is. If you want to remind yourself daily how small you are, you can download the wallpaper-sized version of the deep field image from the ESA's JWST website. So yes, that every object in there is a galaxy. It's pretty amazing stuff. All right, I think it's time for a little bit of Tamitha. A little bit of Tamitha. How's that song go? Let me cue up a little bit of Tamitha. Where is she? There she is. All right, now I've got to make sure that my audio levels stay good here. So I've got to put my headphones on and make sure that when I run Tamitha that I don't over-modulate in any great way. So I think I'm ready to hear myself. Yep. Oh, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That doesn't sound good at all. Anyway, all right, let's see if we can play Timothy.
We have multiple solar storms that are going to graze Earth, some gorgeous eye candy, and of course, some fast solar wind. Those stories and more are in this spotlight. If you want to learn how weather from our star causes impacts at the Earth that shape the future of our world, join Professors Dr. Jenny Meehan, Michael Cook, and myself as we guide you through a space weather certificate program like no other. To enroll in the Space Weather and Environment Science program offered at Millersville University, go to millersville.edu/SWEN. It's weather for the 21st century. This forecast also sponsored in part by CW Ops. Space weather this week has given us a lot to look at. As we take a look at our Earth-facing disk, we don't have a lot of active regions in Earth view. Region 4079 looks intimidating, but it's actually been underperforming in terms of solar flares. However, it has been the seat of a lot of activity, along with this coronal hole region right here. This whole area right in here is very unstable. In fact, back on the 5th, you can see kind of a stealthy solar storm launch that triggers this filament, whoosh, to launch off like that. That has given us a solar storm going to the northeast and a solar storm going to the southeast. So likely Earth is only going to get a glancing blow. But we will be following with this fast solar wind. This is going to be a bit of a chaser for us. So we're going to be seeing that here over the next few days as well. But believe it or not, this region is not done. As it continues to rotate to center disk, you see this filament here launch really quickly. You'll see it in just a second. Come on. There it goes, launch there. And then you can also see part of a filament right here begin to launch. So we're having something once again going north of us and something going south of us, but likely not going to give Earth anything other than a glancing blow. So Earth just seems to get lucky and not get in the crosshairs this time. Likely though, we will get that fast solar wind all through this jumbled mess. So it's going to give us some enhancement of the solar wind, and likely aurora photographers at high latitudes will get a gorgeous show. Meanwhile, all of these filament launches, and especially this one here and one other I'll show you, have given us some gorgeous eye candy. Look at this filament launch. Whoosh! Isn't that beautiful from Subi's view? But believe it or not, as we go back to AIA, we've got more to talk about. Here is a filament in the northeast. This one is actually wrapped somewhat around the sun's far side, so we've been following it quite closely. It's a very dense structure. And this thing lets go here just over the last 24 hours. And here it is in Subi. You can see it's just a gorgeous, more eye candy for you to enjoy. Look at that monster, not Earth directed. And you can actually see this kind of like a finger, like a catcher's mitt right here. In fact, when I flip to AIA, you can see it much better. And the reason why it looks like a catcher's mitt is because, believe it or not, there actually is a lingering solar storm up in here. You can't see it because they're oftentimes invisible as they move further out away from the sun. But this means that this thing is much more unstable than we think, and it's likely going to lift off here pretty soon. In fact, it might light up all the way down in here, and we're beginning to see some of that now as this kind of have this false eruption right here. You can see part of it kind of trying to tear away. So we're going to be watching this as it continues to evolve and continues to become unstable, and see if any part of that might be Earth directed, because if so, then this one might actually give us a bit more solar storming than the other two will likely do. But aurora photographers, keep your eyes on the sun, because there's a lot of filaments and it sure looks like it could be an active week. Now, switching to our full sun map, we are lucky that Solar Orbiter has now orbited back to the sun's far side, so we can take a look at live images of the full sun again. And just to calibrate you, we've got the front side of the sun. This is SDO AIA imagery in red, and then Solar Orbiter EUI imagery in blue. And just so you know, region 4079, this should calibrate you quite well. That's the big region on the front side that we just talked about. So as I set this full map in motion, you can see old region 4064. That's the one I want you to keep your eyes on. This was a pretty active region Earth side, but on the sun's far far side, it has managed to really start growing. In fact, you can see right here, right around here is when it started firing big solar flares. So this region, along with some new regions that have just been growing on the sun's far side and region 4072, these are the regions to watch out for. In fact, region 4064 is going to return in about 5 days, and it could easily bring big radio blackouts with it, and as well as potential solar storms. These regions aren't going to rotate back into Earth view for about another 10 days, so we have a little time to watch what they're going to do. But amateur radio operators and emergency responders, you have basically through the weekend before this region rotates into Earth view, and you might start seeing the noise and the radio blackouts return. And now, taking a closer look at the solar storms that are on their way to Earth, we switch to our solar storm prediction model, ENLIL. Now, this is NASA's version of the model, and you're looking down at the sun from the North Pole with Earth being off to the right. And I'm going to show you the two solar storms. The first one that was launched to the east of Earth, we're going to see it being launched here, and you can't really see it all that well. There it is. Right there, you can kind of see it's a very wispy thing. It's also to the south of Earth. But this thing looks like if it's going to give anything of a close to a glancing blow as we take a look at our splash screen here. It's really going to happen about midday on the 8th, but we're not expecting all that much. It's going to be ahead of this kind of density rise that we're going to get from that fast, the influence of that fast solar wind that's coming from the south. You can see most of that fast solar wind here on this light blue patch to the south. So we're not expecting all that much from this, the first set of solar storms, but you know, the coronagraphs aren't all that pretty, and it looks like there might be a little bit of a partial halo, so I wouldn't be surprised if we got something that we weren't expecting. So just kind of stay on your toes. Now, as we switch to the second solar storm, here we go. This one is going to be a little bit more of a glancing blow, a little bit closer to Earth, because this was that region that rotated, it had rotated a little bit more through the Earth strike zone when it launched. So you'll see that solar storm kind of launch out here. You can definitely see it once again going south of Earth. This one, NASA has it impacting Earth around early on the 9th, probably going to be a little bit on the late side. Hard to tell if that solar wind, the fast solar wind, might actually cause this one to lift up just a little bit. And if so, it definitely will graze Earth and give us a chance for aurora, especially at high latitudes. Either way, it's going to be with this enhancement from the fast solar wind. So aurora photographers, if you're at high latitudes, expect by the 9th and possibly into the 10th to be getting some decent storming. Those of you at mid-latitudes, however, well, we might get a bit of storming. Aurora is going to be pretty sporadic, but the Earth is a bit preconditioned, so it looks like it wants to storm because it's been storming a lot recently. Now, switching to our solar storm conditions and aurora possibilities over the coming week, we are anticipating the fast solar wind along with multiple glancing blows kind of all jumbled together over the next few days. So at high latitudes, NOAA's expecting about minor storm conditions. I've bumped that up to major storm conditions, but likely going to be pretty mild, all things considered. Maybe about a 10% chance of a severe storm at high latitudes, but probably not. And then things will kind of calm down a little bit as we get into the 10th and the 11th. Likely we're going to see some fast solar wind continuing through the 11th before things finally begin to calm down. So aurora photographers, if you're at high latitudes, you will definitely get a lot of chances here in the future over the rest of this week to catch some great shows. Now at mid latitudes, while we're only expecting minor storm conditions, we've got maybe about a 10% chance of a major storm right around the 9th. And this is because of the impact from those solar storms along with that fast solar wind. But by the 10th and the 11th, we're only expecting active to possibly unsettled conditions with a little chance for a minor storm. So aurora photographers, if you're at mid latitudes, well, only if you're dedicated should you chase. And now switching to our solar flare and dayside radio blackout outlook over the coming week, we are sitting in the mid 160s for solar flux, which would usually mean you have good dayside radio propagation. But right now we are sitting at moderate noise on the bands, and this is because we have those active regions, especially region 47 79 that's giving us some trouble. NOAA's giving us about a 45% chance of M-class flares at the R1 to R2 level radio blackout and about a 5% chance of X-class flares at an R3 level radio blackout. And that's going to be extended easily through the 10th, possibly the 11th, but then things might actually rise a little bit because we're going to have old region 4064 rotating back into Earth view, and it could definitely up the chance for radio blackouts and even more noise on the band. So amateur radio operators, be ready for that. Meanwhile, as we take a look at our radiation storm and polar aviation outlook over the coming week, we are sitting at the D1 normal range. We're been slightly elevated earlier today, but pretty much things are going to be back into the quiet range. This is the S0 quiet range and the D1 normal range for you aviators at flight level 360. And likely we're only going to have about a 5% chance of a radiation storm at the S1 or S2 level clear out through the week. So for the most part, we're all in the clear, and hopefully things will continue to stay that way. So the space weather this week is looking pretty active. We have a couple solar storms that are going to give us some glancing blows, and along with some fast solar wind. Aurora photographers, if you're at high latitudes, you could get some nice shows over the course of this week. But aurora photographers at mid latitudes, well, the shows are going to be a little bit more fleeting for you. So only if you're dedicated should you chase. Now, amateur radio operators and emergency responders, well, the noise on the bands isn't too bad right now, and the radio blackouts have kind of calmed down a little bit. But I tell you, in about 5 days, we're going to start seeing those radio blackouts increase again. So enjoy the quiet, and also on Earth's night side, just know that you're going to have a little bit of trouble with radio disruptions during these solar storms. And now you GPS users, well, it isn't too bad on Earth's day side, but on Earth's night side, you're going to need to watch out during these solar storms because it could play and wreak havoc with your GPS signals. So as long as you calibrate your magnetometers often and you stay vigilant, well, then you should be pretty okay. I'm Tamitha Skov, the Space Weather Woman. Thank you for watching.
Okay, thank you, Tamitha. Another excellent audio. Is your audio there? Oh yeah, got to do that, haven't I? Bring that up. Okay, yep, bring it up. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let me just check that on 80 meters. Always helps to have a bit of feedback. 1, 2, 3, 4, 5. Oh yes. Way lots of audio. VK3 EKH, the official station of the Astronomical Society of Victoria. Well, thank you, Tamitha, and I'll run that report a couple of more times this weekend on the ATV side of things. All right, we'll finish up with just a quick look at spaceweather.com and what they're showing on the scheme of things. Let me just bring that up and bring up the sun. Okay, so that's the current view of the sun with about four sunspots there. The solar wind is currently at 448 kilometers per second at a density of 7.55 protons per cubic centimeter. That figure's gone up. The current sunspot number is 84. The radio sun is currently 149. And the Aurora Australis over Antarctica is looking like this. So there's a little bit of an oval there, but not producing much in the way of obvious auroral activity, I'd say. And the coronal hole is also currently looking like this, which is where a lot of those high charged particles are streaming from that Tamitha was referring to. And if we go down a bit further, the KP index, is equal to 1.67, which is considered quiet. The 24-hour max KP figure is up to 4, which is considered as unsettled. Geomagnetic storm watch. NOAA forecasters are predicting a minor G1 class geomagnetic storm on May 9, when that's US time, when a high-speed stream of solar wind is expected to exert pressure on Earth's magnetic field, which is what Tamath has been saying. A glancing blow from a CME, which left the sun on May 5, is also possible, further boosting the odds of a storm. Now, there's a bit of an interesting little graphic running here, a video of sorts. Let me just bring that up. And I've got it on a loop. Okay. On the sun, this is what quiet looks like. All week long, solar activity has been low, with persistent quiet causing the sun's X-ray output to flatline. However, everything is relative. On the sun, this is what quiet actually looks like. So there's, even though the sun's been quiet, you can actually see that there is significant solar flare activity going on. And you've actually, in that image there, they've got the Earth. And why they put the moon there, I don't know, but they've got the Earth there as a scale to how big that prominence is. David Wilson recorded this 2-hour movie. So what you're seeing there is 2 hours compressed. David Wilson recorded this 2-hour movie from his backyard observatory in Inverness, Scotland. He says, I was testing an old Barlow lens on May 7 when I caught sight of this tempest between the clouds. He says, how can a solar tornado big enough to swallow the Earth with 150,000 mile winds be quiet? He says. So for starters, there's no sound in space, of course, but that's not the real reason. Space weather analysts rank solar activity by explosiveness. And if there's an X-ray, an X-class solar flare, forecasters will say solar activity is high. But if there are no flares and no CMEs, the solar activity is low or quiet. This magnificent tornado simply did not explode. So quiet never looked so good. So that's a pretty amazing image, and I am looking forward to be able to capture similar images with my new observatory. How to do it, I don't know, but I am looking forward to that experiment. One other picture here from spaceweather.com is a halo around the sun, an oval sun halo. 99 out of 100 sun halos are perfectly circular. But on May 7th, a person by the name of John Dartnell looked into the blue sky over North Wiltshire in UK and saw 1/100th. This display was oval in shape. I don't know why it says 100th. Anyway, he says, I've never seen a circular sun halos before, but I was mystified by this. And at first I thought it was a lens distortion, but it was definitely oval. And you can kind of make it out that it's oval. So, yes, I don't think I've seen halos around the sun. Maybe I can't recall, but I know around the moon it is. You can see that. All right, as of May 9, 2025, there was 2,349 potentially hazardous asteroids, but none of them are on a collision course with Earth. Okay, I think on that note, we shall conclude for this week at 8 minutes past the hour. So on that note, thank you everybody for listening in and staying with me for the last hour and a bit. I think my streaming services have held up, so that's good to see, although they may fall over now once I start doing a quick callback. All right, this is VK3EKH, listening on 80 metres for any stations that wish to call in. All right. Sorry about that. because I've been monitoring with the headphones, I had the volume in different positions and the monitor on and all that sort of thing. So I got VK3SPX. Who was the station that came in at the beginning there?
VK3 Alpha Oscar Bravo, another old booster.
I thought it might have been. G'day, Brett. VK3ARB, VK3SPX. Anybody else? I've got a bit of a high noise level here tonight. It's a bit of a pain. I was hoping it might have gone by now. All right, have a say, Brett. VK3AOB, VK3EKH.
Fine, please, no worries, yeah. Very good. Most interesting. It's the first time I've seen the space weather watch woman and solar stuff. That's interesting. Is there a satellite the other side of the sun that they do research with? I just wondered about that. But anyway, wonder about that. Back to you.
Yes, there is. There's actually a number of solar probes that observe the sun, and SOHO is one of them. And as Tamitha often points out in her broadcasts, she indicates which probes are looking at which part of the sun. And I think there's stereo A and stereo B. And I think stereo A looks a little bit behind the sun from our perspective, so we get to see what's coming up around the limb of the sun before it actually approaches. So that helps to sort of predict things that's going on. So I think one of them failed actually a few months ago, and there's been a bit of a loss of information because of that. But there's not one so much right behind, but I think it's either SOHO or the stereo A and B. One of those satellites looks slightly at the edge of the sun on the side that's coming around to our view. Sorry, I'm losing my voice now. Tamitha often refers to those particular satellites in her articles. She's normally producing short videos like that every couple of weeks or so, and I try desperately to to keep up with it all because if I can run it on the Friday night session, it often has relevance. She's a ham radio operator herself. Her call sign is W. What is it? W something space weather woman. W something 6 space weather woman. I'm pretty sure I've got that here somewhere. Quickly, I can't see it though. But anyway, I know that she is also a licensed amateur. Anyway, all right. Thanks, Brett, and a mightily good signal coming into Melbourne. It's now Steve, VK3SPX, VK3EKH.
Good to see you. Scope finally assembled. About that. I'm guessing you're probably going to do a bit of optical astronomy first, sort of get the hang of things, and that camera will be handy too, I think, because it's not really just spotting with the eyepiece that go, and I think I find when friends come, I prefer to sit up in the house looking at the images developing from the cool camera and all that sort of thing, and let the automation take over. But generally people want to go out there, they want to look through the damn telescope, actually look through it. So I'm going to hunt around in the cupboard to find out what I've done with the eyepieces and stuff like that. But often people try to look through an eyepiece and you've got to position your eye just right, or you end up being disappointed. And I think that camera you've got probably just positioned exactly right when you slot it into.
I hope so.
And hook up a PC or something to it, and I think it could be really good for showing people what the telescope is looking for without having to sort of contort themselves into the expedition to actually look for the ice. So yeah, that'd be good. And when you get around to really getting the automation right and getting all the software sorted out to do accurate photography, autonomously and what have you, I might be able to give you a bit of a hand there if you need it to lead down this track for quite some time. What else was I going to say? Yeah, that deep sky image is pretty nifty, isn't it? I had to laugh about the diffraction spikes though, because they're just an artifact of the telescope with the mirror held up by the two pieces of metal in front. Because I've got a Celestron strip calibrator that doesn't have diffraction spikes, and I've often felt a bit lucky in that regard, so I did resort at one stage to get a couple of risers from the garden watering system and tape them together and put them across the front of the telescope to react to the diffraction. Anyway, another thing too, if I may, you were talking about the Corona Borealis, I don't know, probably 6 months ago, and that thing was supposed to go nova, and it hasn't done it since. And at the time I looked at that with stellarium, and it wasn't really visible in the southern hemisphere, or in our neck of the woods. If it had gone nova 6 months ago, but now if it goes nova, and it's still expected to happen sometime soonish, we will see it. It's visible in the northern sky about 20 degrees up, so that might be interesting. Anyway, and to top it all off, the Bendigo Club hosted the WA AGM last weekend in Bendigo, as you might know, and went to the dinner there, and we had a contact with the ISS. The club organised for a local school to come along, and about 13 students all asked a question of one of the Japanese astronauts who was on the space station at the time, and that whole thing went off like clockwork, and it was really a highlight of the event. So yeah. Anyway, that's quite enough for me, I think, today, actually. DKP,
Yeah, good on you, Steve. I've got a picture up at the moment of at least one picture up of the dome as it's partially complete. You can see that at the moment, over?
Yep, I can see it. Looks great.
Yeah, cool. That's before it had the shutter installed. Most of that assembly was done yesterday, and when Mark and Diego came back today, they fitted the shutter and then all the two motors and the electrical wiring. So it's basically all complete now. But I mean, just look at that. I have waited so long for this moment, for that dome to be finally assembled and installed and going. So I'm just glad that it's off the grass, because it's been sitting on a pallet, the pallet that it was delivered on, and of course the rats had knurled their way through the bottom of the pallet and the plastic bubble pack in there and got inside the dome. So nothing was damaged, but that rat smell was evident. So after Mark and Diego left today, I got in there with a spray cleaner and went over everything that I could see that was a bit messy looking, and then sprayed copious amounts of aerosol spray thing to try and neutralise the smell. So unfortunately, the smell of a brand new dome, like getting into a nice new car, isn't really the thing at the moment. unfortunately. Although I have no idea what the smell of a brand new dome would be like, to be honest. So it would have to be a fiberglass type smell, whatever that might be. Anyway, there it is. So I'll send you some more pictures. I'll send you more pictures, Steve. I've got a swag of them at different angles and from inside and out. So I'll email you 4 or 5 other images so you can get a bit of a feel for it. But I've got 3 telescopes to experiment with, 2 Saxons, a 12-inch reflector, Newtonian, a 6-inch refractor, Saxon, and the Celestron, the 8-inch CPC 800 XLT, which is probably what will go in there first, actually. Because I really do want to exploit the Celestron and see what I can do with it. And I'm really, really hoping that this camera will, in fact, slot into the eyepiece, as they suggest. So I don't think it'll be that easy somehow, but I do acknowledge what you're saying. It's better to actually look through an eyepiece and allow the brain to do all the work. But the mobile app, the mobile phone app that this works on, has quite a few interesting features associated with it. I've yet to work it and find out what you can do. You can do timer lapse and record and take pictures, of course. But I think the actual app for this camera does a few other interesting things as far as exposure is concerned. So I'll be really interested to see how good that thing works. And of course, what I like about it is the Wi-Fi aspect to it, so I can attach it to the camera and walk around with the mobile phone. I don't know what the range will be, but at least it'll kind of give you that sense of freedom without being attached to the system. But there's a lot for me to learn now, Steve, and I'll take you up on what you say. I'm sure there'll be some questions I'll ask and about the software and all that sort of stuff for doing astrophotography, really. But I just got to work out what cameras to get. So I'm still working on that one. Anyway, on that note, we shall just do one more quick listen on the frequency, and then we shall go clear for the night. VK3 EKH listening on 3541. They all said no. All right. Cheers, everyone. Take care. Look after yourselves. Have a lovely weekend. And thank goodness all the election stuff is now behind us. And we've now got a new pope. Goodness gracious me. And yeah, I won't go any further on that. This is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. For more information about the ASV, go to www.asv.org.au if you want to find out more about the society. Take care, everyone. Look after yourselves. See you next Friday. This is VK3 EKH closing down. Cheers, all.
Yeah, cheers. And, good on you. By the way, if you're sitting around on 40 metres tomorrow, you might hear us activating the Henderson's Mill, the DI3MILLS activation on probably 7.115, I think that's okay. All right, thanks, Cliff. 7:30. Clear.
No worries, Steve. Cheers, mate.
And, yeah, cheers, Cliff. I got the old 5-inch telescope, but I've got the Australian Geographic. I think it's a cheaper little telescope. Wait a minute, I'll just shut you up. You're talking here. I'll just finish with that. Exit, right, no, exit, good, there we go, sorry, but I've got rid of you.
See what it was.
Yeah, I had an old Galaxy S8 cell phone and a Magic Arm, which I bought years ago. It's a Magic Arm brought motion picture television and motion picture and television industry type of thing. An arm with clamps on either end of the knob that you can lock physically say a swivel, and you can clamp one end of it up, you clamp an object in that, and then set it into position, turn the knob and lock it, and it stays that way. So that's basically set up on the eyepiece with the phone looking into the down the guts. And I haven't used it yet. I set it up in the backyard looking at a house, up my back neighbour's house, and it works quite well. But it's very cold outside. It's crystal clear night, and I'm not going out with it tonight. All right. Have a good weekend, and might talk to you next week. VK 3. CSJ, VK3, AOB, clear it off.
No worries, Brett. Yeah, I've got something similar. I've got a dedicated mobile phone adapter. I've played around with it once, but again, that was indoors. I really didn't have the telescope set up outside to be able to really experiment with it. But I did buy an appropriate fitting that's designed to clamp onto the eyepiece, and the mobile phone sits flush up against the eyepiece, and you've got the X and Y adjustments. So it works. How well it works, I'm not sure yet, because, like I say, I haven't had a chance to take it outside and under the sun. But now I can. I've organised a pier of a 600mm pier for the telescope to be mounted on from Sidereal Trading. I've got to wait for that to arrive. So until that pier arrives, I can't really go mounting any of the other telescopes, but I can install the Celestron on its tripod. That should work for the time being. So I might take down the Celestron to the telescope tomorrow, and see what transpires for the rest of this weekend. I can see myself being up till 3 o'clock in the morning tomorrow if the sky is clear. So it starts. I'm a natural late person anyway, but I can see myself being out there in that dome, freezing to death. I hope it won't be that bad. Anyway, we'll see. We'll have to work out all these tricks about trying to keep warm. Anyway, all right. Cheers for now, Brett.
Yeah. Okay. Clear it off. Going that way.